With C, we recognize the ether oxygen coming off of that ring right there. Our first step is to see how many carbons are on either side of the two chains coming off that. We have 2 carbons to the right, and in this ring to the left, we have 1, 2, 3, 4, 5, and 6. So the ring to the left has more carbons, and this is going to be the backbone. Now I'll erase those numbers because I may have numbered them in the wrong direction. I may not have, just I don't know yet. So that is our backbone because it has more carbons. And we'll name that backbone as if there were no branches on it. After we do that, we'll worry about the branches. Now that is a strange backbone. It's a very particular, very special molecule. If you ever see a 6-membered ring with alternating single or double bonds, or another way you might see this is a 6-membered ring with a circle inside, that is a special molecule called benzene that we'll talk much more about. It has a couple chapters just devoted to it. And the thing you might remember about it, what's significant about it, is that it's really stable. It doesn't react it's hard to get it to react. And it's also very rigid. So it keeps its shape really well. And so you tend to see it in a lot of medications and biologically active drugs, or biologically active molecules, because if it keeps its shape really well, it'll fit into pockets very reliably. Anyway, benzene. There's no way you could have gotten this from this IUPAC table. It's just a common name, or a special name, for a special molecule. So that's our backbone, benzene. Now that we've named the backbone, you will go to the branches. We'll start with the ether branches. We have our oxygen and the carbon chain. Now the carbon chain has 2 carbons, and so the prefix is going to be F. And as we saw before, the oxygen is represented by an oxy, so the branch is going to be F-oxy. We also saw previously that when you have a group, one of the halogens, those are the elements in group 7A on the periodic table, you name them as branches by taking the first syllable and adding an O. So we have 2 chlorines here. You take the first syllable, chlor, and add the ending O. Take the first syllable, chlor, and add the ending O. And in fact, when you have more than one of the same type of branch, so these are both chloro branches, you can sort of smush them together and just put a prefix in front. So chloro, and put a prefix in front of there to give a sign of how many of those branches you put together. So we smushed 2 together, so dichloro. Okay, now we have to think about where these branches are coming off of the backbone. And so where should we start numbering on this ring? Should we number it so that the ether gets the lowest number, so that's number 1? Or should we number it so that one of the carbons with the chlorines get the lowest number? Should those be number 1? To answer that question, anytime you have different types of branches and you're wondering which should get the lowest number, the IUPAC, International Union of Pure and Applied Chemistry, developed a table that lists the branches in order of most important to least important. In other words, in order from the ones that should get the lowest number to the ones that get the higher number. So these are less important. So this is something that was developed by convention by the International Union of Pure and Applied Chemistry, and I put it at the end of your homework set. So here we have 2 things. We have an ether, and you can see the ether is way down here, but then just below it you have the halogens, fluorine, chlorine, bromine, and iodine. So because the ether is higher, the ether is more important here, and the ether should get the lower number. So we're going to number that benzene ring so the ether gets the lower number. So this is going to get a 1, and then you couldn't start numbering this clockwise or counterclockwise, you get lower numbers for the chlorines if you go counterclockwise. So we have 1-ethoxy, 2-chloro, 4-chloro. When you smush them together, you put the numbers in front, separated by a comma. In between numbers and letters goes a dash. So 2,4-dichloro. So those are our puzzle pieces, and we just have to put them in the right order. The backbone name always comes last. When you're looking at these other two names, you put them in alphabetical order. You ignore the prefix, though, so we're really comparing C with E. And because C comes first in the alphabet, the branch that has that will come first in the name. So we have 2,4-dichloro, and then 1-ethoxy. And always between numbers and letters goes a dash. So, the name for this beautiful molecule is 2,4-dichloro 1-ethoxybenzene.